Hello wonderful person, this is Anton, and today we're going to discuss some of the recent discoveries in regards to the mysteries of plate tectonics on planet Earth. And more specifically, a recent study that possibly connects the origins of plate tectonics and a lot of other important geological activity on the planet to a major cataclysmic event that happened on the planet 4.5 billion years ago, the one responsible for the formation of the moon. But more importantly, all of this connects to something that's still inside our planet even today, and something that even today causes a few anomalies on planet Earth. And so let's discuss this in a little bit more detail, but I guess first let's start with the mystery where all of this begins. And this unusual mystery was discovered back in the 1980s. It was basically detected by listening to various earthquakes pass through the entire planet in order to visualize and in order to image the internal structure of planet Earth. This is of course how we know the Earth contains the inner core, the outer core, the newly discovered innermost inner core that you can learn more about in one of the videos in the description, and of course the mantle and so on. But as the scientists were listening to these seismic waves, in certain regions, for some reason the waves were traveling a little bit slower. You can see these regions in red. And when visualized, it sort of appeared like this. There was a large blob in the Pacific and a large blob somewhere beneath Africa. And over the years, as more and more data became available, these unusually large, continent-sized blobs basically became a hot new topic, because they appear to be actual structures inside the planet. Structures through which seismic waves traveled much slower, and as a result they became known as LLSVP, large, low shear velocity provinces, also known as low velocity provinces, that seem to be inside the mantle, but right above the outer core. And for many years, basically for decades now, it was kind of assumed at first that this was maybe the result of plate tectonics, or basically the result of various continental plates moving across, going one under the other, sinking deep into the Earth's mantle as a result of plate subduction, and at some point basically sinking all the way to the bottom and falling into something sometimes referred to as the plate tectonic graveyard. The area where a lot of different plates possibly end up mixing together and producing relatively large chunks. Most of these though would be probably oceanic plates, as they're slightly more dense and would thus sink easier. And this was essentially the main explanation for many years, with even recent studies basically proposing that a lot of these blobs possibly changed in shape, very likely assembling and breaking up over and over in a very similar way to continents. With this recent study that you can find in the description, even suggesting that, for example, the African blob must have only formed 60 million years ago. And a small fun fact, the now famous South Atlantic anomaly, the unusual magnetic anomaly that decreases the overall field in the region right here, has actually been connected to this unusual blob. As a matter of fact, it might be directly responsible for it. You can learn more about the anomaly in one of the videos in the description. But much more importantly than the magnetic anomaly is the fact that these unusual blobs are also connected to giant volcanic eruptions that are usually formed through deep mantle plumes. Or in other words, a lot of massive plumes that formed some of the biggest volcanoes on the planet, including the ones around the time the dinosaurs went extinct, are also directly connected to the existence of these low-velocity provinces, or these huge blobs. As a matter of fact, these blobs are believed to be so important that they now unofficially have nicknames. One of them is known as Tuzo, and the other one is Jason, named after two geologists that spent a lot of time studying them. And these are actually really large. Approximately 6% of the entire planet are inside these blobs. But naturally they're still kind of mysterious. And because they're so mysterious, there are additional explanations and some ideas that are maybe a little bit more, I guess, out of the box. And one such idea started to become even more popular in the last few years. The idea that these unusual blobs were actually the result of Theia colliding with earlier Earth, the event that produced our moon, but also deposited some of these chunks inside planet Earth. Or in other words, this basically explains these blobs as leftovers of an ancient planetesimal that collided with our planet. The planetesimal that then basically got deposited inside planet Earth and is still there today in two separate chunks, which actually suggests that it's been around for over 4.4 billion years. And a few videos in the description discuss this proposition and all of the evidence in a lot of detail. And so right now, more and more scientists are sort of changing their mind about the origin of these blobs. The evidence here basically suggests that these are more likely to be leftovers of Theia as opposed to ancient continents, with all of this mostly based on a lot of recent simulations. For example, collisional simulations suggest that leftovers should be deposited somewhere near the core. And though previous counter-explanations suggested that this is unlikely to happen because such a violent collision will very likely stir up the mantle, changing the composition too much, a lot of more recent simulations suggest otherwise. They actually do reproduce modern Earth by using a supercomputer simulation with a lot of particles. But more importantly, they do end up with some leftovers very close to that mantle core boundary, or basically the location where we find these blobs. But this recent study goes a step further. It actually conducts additional simulations discovering something really important. Here the focus is on immediate turbulence following the impact with Theia and following the sinking of these chunks deep into the mantle. And turns out that almost right away, within just a few million years, something starts happening inside. It's sort of visible right here. Basically, this new, dense and hot material makes mantle very turbulent, dramatically increasing convection on the inside, producing a lot of mega plumes, which within just 200 million years does something very important. It breaks apart the crust on the surface, forming continental plates and starting the idea of plate tectonics. And so the cracking of crust that began plate tectonics, which now we know lasted for at least 4.3 billion years, potentially began as a result of this collision and as a result of sinking of huge amounts of Theia leftovers, which would then deliver a lot of new material to the mantle that's just a little bit different in composition. And so because parts of Theia were probably a lot more iron-rich and a lot denser, but also very likely contained a lot of heavier isotopes, such as for example uranium and thorium, this suddenly dramatically increased the temperature in certain parts of the planet, thus causing the plumes to form and thus resulting in much more energetic convection, with plumes breaking apart the crust. And interestingly, if this hypothesis is correct, it basically implies that this single impact had a huge influence on planet Earth, dramatically changing its history for the next 4.5 billion years. Basically creating this unusual geological process that's still going on today, which is of course plate tectonics, which we know is super important in order to keep the planet habitable for a long period of time. Also potentially explaining why Earth is so unique compared to a lot of other planets we've seen so far, but also giving us something to look for, possibly other planets with large moons that might have been created as a result of a major collision. And by the way, we actually do believe a lot of planets in the solar system experienced collisions in the past. For example, both Mercury and Venus could have also received collisions in the past. These videos are also somewhere right there. And so, according to the researchers and the hypothesis, the collision with Theia was a lot more important than just forming a moon. It might have been also responsible for basically providing conditions for life to form, which, if correct, is obviously super important. But naturally, because this is such a wild proposition, not everyone agrees with this. As a matter of fact, there are quite a lot of alternative explanations to how plate tectonics potentially started. For example, one of them suggests that maybe it was actually the result of the moon stirring the planet so much when it was much closer to Earth that the tidal effects from the moon and the sun basically cracked the Earth open. Or maybe back then Earth was just much hotter and produced a lot of these super plumes that cracked the Earth in different ways. And so basically even today there is still no definitive answer. But most importantly, because of these simulations and new studies, we're once again reminded by how extremely unusual, rare and special our planet is. Definitely different from anything else out there, and definitely something that we always forget. And so for all we know, this idea of rare Earth hypothesis might be onto something after all. But anyway, at least for now that's kind of all we have, and I'm sure there will be more studies in the next few months providing additional evidence. And so once we have some updates about LLSVPs, their origin, and what exactly they're doing to our planet, we'll come back and talk more about this in some of the future videos. Until then, thank you for watching, subscribe, share this with someone who loves learning about space and sciences, come back tomorrow to learn something else, support the channel on Patreon by joining a channel membership, or by buying the Wonderful Person t-shirt you can find in the description. Stay wonderful, I'll see you tomorrow, and as always, bye bye.